Okay. So now see in the last class we started to work with this new data structure called as linked list. We have to make progress, but the idea though is generally is if when we don't know the number of the amount of data that we have to store and process, then we get into few challenges. So what are the challenges? Like, for example, if you start with some kind of fixed allocation, like for example, let's say we say student underscore record student underscore db, some, let's say 1000. Okay. So if you declare a global array, an array of 1000 records, when we declare an array of 1000 records, then two possibilities. This could be this 1000. No, there are two possibilities. It could be a overestimate. Or it could be an underestimate. So if it is an overestimate, then in this particular case, it's not really a big deal. 1000 student records, it's hardly any memory, but in real practice, the numbers wouldn't look like this. So these are the two problems, and in order to solve this problem, what we did is we start with initially with some amount of initial allocation using malloc. So in this approach, we are allocating memory in the global data segment. Global data segment. So in order to solve this problem, we use malloc, and then we keep keep readjusting by making calls to realloc. But this is also a pretty expensive procedure, because every time we make a call to realloc, there is a lot of background work that happens. So this is an expensive procedure. But the important thing in both these cases, so here the memory is allocated on the heap. But the important thing though, in both these cases is the student database is stored as a linear array of records. Important observation. Student records are stored in memory linearly. This is that is one after another. So this is the important point you need to keep in mind in both these approaches. So now we will see a alternate approach. It's a nonlinear data structure. Nonlinear. Why it's nonlinear? We will see. Nonlinear data structure. And it is allocated. It is stored on heap. Non-linear data structure. It is stored on the heap memory. The advantage is, you can exactly allocate how much, if there are, you can handle an arbitrary number of student records. That's not a problem at all. You can have 1000, 10,000, up to the extent your memory the physical memory supports, we can work with this, we can handle the data nicely. But of course, nothing comes for free. The reason there are challenges here, you will see some performance challenges, because what happens is your data is spread all over the heap and it's no longer linear, and it poses some problems for us. So for example, if this is the heap, if this is your heap of memory, then what happens is initially, you allocate some chunk of memory, and then this chunk of, and then after that you first read one student record, you create, you allocate memory for it, and you store the data, and then you see one more record, and then you create new thing, and then you you read one more record, you allocate one more chunk of memory from the heap, and then now we kind of link all these records together through these links, and that's the reason why this is called as a linked list. All right, so let's try to see this, how this thing works, and we will by through code, and we will see how it goes. We will continue the coding exercise that we started from last time. So what we have is on line number 7 to line number 11, we have this student record with 3 fields. One field on line number 8, it stores a pointer to name, it's a character pointer, and the field on line 9, it stores marks, and the field on line 10, it is a next record pointer. It's a next record pointer. It holds the address of the next record in the memory. And we on line number 13, what do we have? We have a variable called as head. It is of type student record pointer. It holds a pointer to this linked list. So let's see. So what it means is, if this is our linked list, so head is another variable. This is our variable head. Head contains the address of the first record in this linked list. So if you want to traverse this linked list, you need to have a handle, right? So head provides the handle to the first record in this linked list. And using this, we keep moving, and this is next. So whatever this is, all this is the next field. Next field contains the address of the next record in this list. So now let's see what we are doing. So recall, this is our main. In main, we first call read student database function, and initially when we start, head is nil because the linked list is nil. There's nothing there in the linked list, so head contains null, and that's what is being done on line number 13 here. And now let's come to read student DB function. So in every iteration of the loop, we are reading a student record. And yeah, that's what we are. And once we hit a end of file, we come out of this this read function. That's all. So yeah, on line number 21, we are reading the name, and on line number 22, we are reading the corresponding marks. So we have to allocate a student record here. So what do we do? So first of all, we say, what should be the malloc function? What should we give to malloc? What is the parameter to malloc here? Are you all here? Or size of memory to be allocated? What is the size of the memory? We have to allocate memory to hold one student record, right? No, we have to allocate memory to hold one student record, size of student record. Yeah, that's true. Size of student underscore record. Are you with me here? Okay, that is the amount of memory we have to allocate memory for one student record. But allocating memory for one student record, and do we need to allocate any more extra memory? Yeah, for name we have to allocate. Yeah, so now I am introducing new syntax. S record is a pointer, student record S record for individual name. Yeah, S record, it is a pointer to a structure, and so when you want to access the fields of a structure by using the pointer, we use this notation, this arrow notation, name. So remember, if it is not T record, temp record, let's call it as temp record. So temp record is not a pointer here. So if it's temp record is not a pointer, it's just a regular variable. And if you want to access the field name, we use the dot operator. But S record is a pointer. So whenever it's a pointer to a memory which holds that particular kind of record structure, we use this operator to access the field. Are you with me? The difference between temp record and S record? S record is a pointer, whereas temp record is not a pointer. It's the name of the memory location. S record contains, what does S record contains? The address. S record contains the address of the structure in the memory. When you have the address, so when you want to access the fields of a structure using the corresponding pointer variable, we have to use this notation. This operator we have to use. Okay. So technically what happens is, it is possible, Bow. So Bow has another approach, I think, which can work. Sorry. An alternate approach here is, we can use a star S record dot name. This may also work. Star S record dot name. Okay. So essentially what compiler will do here in this case by using this operator, so S record contains the base address, right? So let's say this is the memory and this is S record. S record, let's say contains address A0. A0 is the place where the structure is actually present, and within that name is present somewhere. So what happens is this operator, it will take A0 is the base address. It will take A0 and add and try to find the offset of the name within this structure. What is the offset at which the name is present within the structure? What is the offset at which name is present within the structure? What's the offset? 0, na? Because within the structure, name is present at the beginning, right? Yes or no? Are you with me? It uses that offset, it uses the base address of the structure, and it uses the offset of the field within that structure to figure out the exact memory location at which the corresponding update needs to be maintained. Okay, that's what happens. In this particular case, the offset is 0, so it just adds 0, and it finds out the base address of the memory location which needs to be updated. And then what should we have here? What is the char star mloc strlen temp name +1. Okay, let's clear this. And then string copy this record name temp. Okay, so now we have successfully created one S record, one student record corresponding to the current data that we have read. So now we have to update our linked list. Okay, we will do one very simple way of updating the linked list. So what we do is we say S record, and not only that, we say S record dot next is equal to head, and head is equal to S record. So if this is the current state, so let's say if this is the current state of the linked list, and if we have created a new node we have created, what will this do? What will line number 28 do? What will line number 28 do? Line number 28 says S record of next is equal to whatever head is pointing to, make this new record point to. Does this make sense? Line number 28. And then line number 29 says, now make head point to this. Are you all with me? This is line number 28. This is L28 and this is L29. And in the base case, that is, you really have to, so we are inserting a node. Yeah, that's true. So the base case is important. The base case is, we are adding elements to the start of the linked list now. Good observation. Yeah. So we are adding elements to the start of the linked list. It may be the right thing to do or may not be the right thing to do. It depends on the application. But just now, in order to make our job easy, we are just adding it to the beginning of the linked list. The base case is when there is no linked list, what will head contain? Head contains null, right? So head contains null. So now when we create a new record, this is our new record. This is our new record. And then what do? We make this point to null because S record next is equal to head, head is equal to null. So this will be equal to null. And then head will point to this. Are you with me here? How the base case works? When we insert the first node, the next link of the first node will be null. So in other words, if you see, this will be equal to null. This will be equal to null. So this is important because when we want to traverse this linker list starting from the left to the right, we keep going until we get the next hits the null. When next hits the null, we will understand that we hit the last node in a linked list, and there we will stop. Are you all with me here? All right. So now it's very simple. If you understood this much, then we are all in awesome state. Void print student db. Put in the memory allocated in line 25. No, it will, Srija, on line number 25, we allocate memory. This is a very important point. I cannot stress enough. We just allocate memory which is big enough to hold a pointer to a string. The pointer to a character pointer is always 8 bytes, but your name could be Srija is 5 bytes and Parth is again 5 bytes, and Srija is 6 bytes, and like that. So because of that, we have to reallocate memory for the name. So in order to make that point only, I had this. Otherwise, an easy thing, at least for this session, would be something simple like char name 10, okay, or 30. If we do this, then we don't need separate allocation of memory for name. Are you all with me? When we allocate memory for structure, then it will be automatically allocated if you use this approach. But I want to make it clear for you that but char star name, when we use, we have to do memory allocation separately. So that's the reason why I am taking this approach. Slightly involved, confusing, but it is essential to get it clear. Okay, so now we want to print. So while printing, when we are in nonlinear data structures or irregular data structures or pointer based data structures like what we are seeing, we use usually 2 fingers to move to kind of traverse a data structure. Okay, so here what we do is very simple. So we will say current node is equal to head. We start with the head. Okay, student underscore student record underscore current node. We start with the head, and we keep going until current node becomes seek null. We will see how it works. And then here current node is equal to current node next. So what do we do? So remember, so let me again explain what happens. So you start the loop at the current node. This is one. You start with the current node, that is the current node initially points to the first node in the list. Are you with me? Current node contains the first element in the list. Like for example, here, when we start the loop, current node will be pointing to this node. Or rather, because this is the updated list, current node will point to, let me use this. Okay, so current node will start with the first element in this list. All right. And then what do? We just want to print printf, okay, percentage /t percentage current node name, current node marks, that's it. And then after we process the current node, what are we doing? We are going, so this is 2. Sorry, let me use red. This is the step 2, and after that we go here and we use next to move from, we move current node to the next node. Okay, so we use current node is equal to current node next. Okay, we go to the next node. And then we check, after we go to the next node, I mean, we are checking here whether it is equal to null or not. So technically speaking, it's not equal to null. I can write it like this. Does this loop make sense? Marks are not given into. They are given line number 25. Line number 25. Oh, we didn't copy. Yeah? Okay. 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 Great. Thank you. Nice. Yes, record marks is equal to marks. Let me clear this whole picture so that you can see the code clear. Does this code make sense, guys? Line number function 35, print student database. We start with the beginning of the node, beginning of the linked list. We process, we keep moving forward. And when we hit the null, then we stop. That means we have traversed the whole linked list. As simple as that. Print student VB. Let's see how this works. GCC list.c. Just write it down. See now, what's the advantage? You can. So what is the advantage now? Can we have as many names as we want? Okay, we didn't have Naveen, so Naveen gets 50. Okay, Akshit's name is there already. No, Akshit's name is not there. Akshit 49. So I don't need to do anything. So Jainit's name is already there. Okay, let's say Srija is okay. So on and so forth. So now that's it. I don't need to do anything. It's all there. The only thing you see is the names are stored. When we print them, they are printed in the opposite order because we are moving, storing names at the beginning of the list. We are inserting names at the beginning of the list. Are you all with me on this example? How linked list work? Make sense? And you can think of more interesting operations, like usually when we work on any database, the things that we want to do in any database. Number 1, insert operation. Number 2, delete. Number 3, search. So these are what are called as 3 important dictionary operations, dictionary data structures. So insert, delete, and search. So how can we access one of these structures? How to reverse a linked list? Reversing a linked list sort. There are other things. Reversing a linked list is one of the. It's not. It's a fun thing to do for the first time, but after that, who cares about reversing a linked list? Usually, as to the best of my knowledge, I never found myself trying to reverse a linked list except in some interview or some exam. Okay. So okay, so the thing here is, let's say we can, there is this question, how can I access just one of these structures? So let's do one thing. We will do, so right now we are printing this whole thing, right? So but we can have something like student underscore record star search db, and search, you want to search a name by the record, the database, by using a name as the key. Whenever we want to search, there should be a key again using which we do the search. So what do we do? So we do for student we traverse, and then so we, what we do is if strcmp name current node name, if it is equal to 0, then return student record. This is, we are doing what is called as a linear search now. We are going through the list and we are trying to find a record with the corresponding name. If we find the name, we will go to line number 46 at some point in time. Otherwise, we come here. Oh, sorry, it's written current. Thank you. And then here, let's say, yeah, you print the database, and then after you print, yeah, so while printing the database, let's do some beautification. Not really big, but still some. /n /n. So now let's say while one percentage search key search key 100 if string compare search key with fit equal to 0, then break. Otherwise, what do? We call search db search key record. You are seeing what we are trying to do. If record is equal to null, percentage not found in the database /n searched. Yeah. And else, what do we do? Printf %s /t/t %d/n record name. Okay, yeah. Record marks. Okay. So let's see if this works or not. Oh, no errors. The only problem is it tries to read from the names. What should I do? Okay, I have an idea. Okay. So now it read the names. So let's say if I give name Nipun, it gives Nipun Smarts. So let's say Aditya. We can use open file, but no, we just have to write code for it. Yeah. We can do it actually. Why not? We'll do it in a couple of minutes. So that's all. So now let's say Advait is not there, I guess. Let's see. Advait. Okay. Quit. That's it. Awesome program. 40 minutes. And in order to complete the story, we can do one thing. Did you studied about files, right? Files you studied, Rana? So we will do one simple thing. Fscanf, fp, fscanf, fp. So we want to open a file in the read mode. The file that we have opened, we are passing it as a parameter, read student DB. Do you think it will work? Let's see. Have to close the file. Okay, it's okay. Usually, when you are not writing the file, even if you don't close the file, nothing happens. Okay, so now let's see. And names.txt. Yes, that's it. Good. So now let's see, Mitansh. Got it. Okay, cool. So now you have this is how databases work. Now you have written some small mini database which can support insert, but it only reads we are supporting only search operation, but you can support insert and delete also. It's not really that difficult. Any questions? Make sense? Are you all with me? Happy? Nice, very nice. So Pawan has this question, why we can't use, previously, in the previous program, why we can't use, the problem is when we use dot in the previous version of the program, when we use this, we would like to give input through keyboard only. Through keyboard also, we want names.txt to be read from this file, but the rest of the commands to be given from the keyboard. But when we do this, what happens is it's not possible. You cannot have part of the input from file and part from the keyboard by using the indirection operator. Okay. So actually, in practice, when if you want to test this actually, even like this, you just have to go to like for example names.txt and do some stuff which is anyway, let's not get there. Okay, so the problem is this, the problem is when we do indirection operator, everything comes from the file, but we want to give some input through keyboard also, that is search keys, quit, everything we want to give at the keyboard. So that's the reason we don't want to use this. What was the reason for reverse order in list? There is no reason. It was easy to code for me, so I used it. What happened? Some problem with Zoom. Are you able to see me? See me means see the screen. There is some stuff here I want to remove, but it is not showing up. Okay, so now it is better. So let's say if you want to, how can we fix the, so part of the problems that we give in the next assignment are, like how to fix the problems, the linked list.c. Right now we are inserting at the beginning, how we can insert it at the end. It's not very difficult, it's so shall we do that and to conclude today's lecture, so that we will and the more interesting question is, can you take this linked list and then say create a new sort the linked list? Okay, that's another interesting problem, like how you can sort the linked list. How do you, that's nice problem. So, but anyway, so before we do that, maybe I will leave that sorting a linked list problem to you, but at least we can try to see how we can so how we can insert the elements at the end. So towards this, what we need first is, so we need 2 pointers if this is our linked list, and when we add a new element, we would like to add it to the end of the linked list, not to the end. That's what we did, right? No. So all we have to do is we don't need to do it, and we are making right now head point to this. all we have to do is we have to what should we do? That's what we are doing, right? So the newly read element, oh, okay, since we are printing it from here, okay, understood. If we just make this one perhaps we can see that yeah, we have to make it point like this and head all these points to head points here and yeah, head tail. Okay, so what we do is we maintain two variables. Now let's try to see if this works. We can keep track of address of the last node. Okay, let's try to see. You read a record and I think we have to do one small thing here. You create till this point, the story is okay. I am doing perhaps there could be a better and cleaner way of doing it. And I'm just thinking if head is equal to null, then head is equal to S record, tail is equal to S record. Okay. And S record next is equal to null and continue. So this is the case when the list is initially empty. Does this make sense? Line number 31 to 36 when the list is initially empty. We are trying to keep track of two pointers, like what is the beginning of the list and what is the end of the list. Are you okay with line number 31 to 36? When it is empty, we are doing this bookkeeping. Okay. But if that is not the case, then so after that, the story is simple. Yes, record the new record that we insert, we should insert it what should we do? Tail next is equal to test record. And actually, we should also do one thing. Test record next all the time. No need to do anything. Does this work? We are adding the linked list at the tail. How many of you are with me on this code? So this is yeah, the way we are doing this is actually like this. Head is pointing here, this is head is pointing to here and tail points here. When we have a new record, we are saying tail next is the new student record and then we have moved tail to this. This one corresponds to, if I mark it in green, so this is, and this corresponds to line number 37, and this corresponds to line number 38. And when we want to traverse, we just start from the head and we keep going like this. Are you okay with this one? This whole story? Shall we run the program and see? Do we need to make any other changes? We need to make few changes in the print DB. We start with head and current node next. It still works actually. Print DB still works. Line number 34, 35. No, line number 34 is required. 34, 35 is required. And for search also, we start with the head. I think everything should work. Let's see. I don't see any problem. GCC linker list.c .a.out names.text. Yeah, so now it's all in order. Awesome. Okay. Let's see if search works. That's it. Okay. Okay, guys. So makes sense, right? Are you all with me here? Happy? Okay, then. Well, that's all for today. Yeah, so you're all doing good, fantastic. I think it's a good class of coding.